Hi, it's good to have you back. My name is Olatunde. From our previous lecture, we learned about fractions, percentages, and decimal. We learned how to convert fractions to decimal, how to convert decimals to fraction, how to convert fractions to percentage, how to convert percentage to fraction. We also learned how to convert percentages to decimals and percentages to fraction. And then we finally saw how to solve problems connecting fractions, decimals, and percentage. In this lecture, we are going to learn about prime numbers and prime factors. We are also going to learn how to write numbers as product of its prime factors using index form. We are going to identify common multiples of two or more numbers. We are going to be able to find the LCM of two or more numbers. You should also be able to identify common factors of two or more numbers, and finally, find the HCF of two or more numbers. Join me as we delve into the topics. Let us begin by discussing prime numbers and prime factors. But first, what are numbers? Numbers are the digits that are used in mathematics. For the sake of this lecture, our numbers, we're going to consider them from 0, 1, 2, 3, etc. So now that we know what numbers are, what are prime numbers? Prime numbers are numbers that can divide itself and can be divided by only 1. Example of prime numbers are 2, 3, 5, 7, 9. 9 is not a prime number. Don't get confused. Let's take them again. 2, 3, 5, 7, 11. However, let me show you a quick tip on how to generate prime numbers. I have a table that is shown above. Now, in that table, you see numbers ranging from 1 to 100. 1 should be struck out because 1 is not a prime number. 2 will not be struck out, but all multiples of 2 will be struck out. That is 4, 6, 8, 12, 16, and the rest. 3 will not be struck out, but all multiples of 3 will be struck out. That is 9, 12, 18, 21, 27, and the rest. Also, we're not going to strike out 5, but we're going to strike out all multiples of 5. That is 10, 15, 25, 30, and the rest. We're also not going to strike out 7, but we're going to strike out all multiples of 7. 14, 21, 28, 49, and the rest. Now, after doing all of this, the numbers that you have left that are prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 87, 89, 91, and 97. All of these numbers are prime numbers between 1 and 100. Now let us discuss about prime factors. But before we talk about prime factors, we need to know what factors are. What are factors? Factors are numbers that can divide a given number without a remainder. Take for example, the factors of 4 are 1, 2, and 4. Because 1 can successfully divide 4 to give 4, 2 can successfully divide 4 to give 2, and 4 can successfully divide 4 to give 1. Take another example, 20. All factors of 20 include 1, 2, 5, 10, and 20. Now, what are prime factors? Among the factors of 4, we need to take out the numbers that are prime. So, prime factors are the prime numbers that are contained in a given factor of a number. For example, we mentioned 4 earlier, that the factors of 4 are 1, 2, and 4. Prime factor of 4 simply therefore is 2, because 2 is the only prime number amongst the factors of 1, 2, and 4. Also, 20 we mentioned earlier, we said the factors of 20 are 1, 2, 4, 5, 10, and 20. However, among these numbers, the prime factors are simply 2, 5. So 2 and 5 are the prime factors of 20. Let us now consider some examples. We are expected to write the factors of 36. Now, to get factors of 36, the first step you need to do is to write 1 and 36. The next is to find all possible factors of 36. How do you do that? You use the multiplication table to check all numbers that can go successfully in 36. After doing that, you should arrive at numbers 1, 36, 2, 3, 4, 6, 9, 12, and 18. Now, how do you know that these are factors? You simply combine them by multiplying them. 1 by 36 will give 36. 2 multiplied by 18 will also give 36. 3 multiplied by 12 will give 36. 4 multiplied by 9 will give 36. And 6 multiplied by 6 will give 36. Then we rearrange the factors. So the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. The second example is to write the factors of 40. First, we begin by writing 1 and then 40. Then we'll use the multiplication table to find out all other numbers that can go successfully in 40. We arrive at 2, 4, 5, 8, 10, 20, and 40. And then to verify if these factors are correct, we combine them in multiplication form. 1 multiplied by 40 gives 40. 2 multiplied by 20 gives 40. 4 multiplied by 10 gives 40. 5 multiplied by 8 also gives 40. So we conclude that all the factors of 40 are 1, 2, 4, 5, 8, 10, 20, and 40. Let us now move to the next section. In this section, we're going to be talking about index notation and prime factorization. Take for example, if I multiply 2 by 2 by 2 by 2 by 2, that is 5 2's that I am multiplying together. A shorthand way of writing that is simply writing 2 with a 5 on top of the 2, which you pronounce as 2 raised to the power of 5. Another example is if I multiply 11 by 11 by 11 by another 11. How do I write that? I simply write it as 11 raised to the power of 4 because I am multiplying 4 11s. Another example is multiplying 3 by 3 by 3. I'm going to write it as 3 raised to the power of 3 because that is 3 3's that I am multiplying together. Let us now take a standard example. I'm trying to express 125 as index notation. How do we do that? First off, we have to write out all the factors of 125. And the factors are 1, 5, 25, and 125. An easier way to start the calculation is by picking two of the factors that multiply each other such that we arrive at 125. So I start with 5 multiplying 25. Now I need to break down 25 into its own factor, and that is also another 5 multiplied by another 5 to get 25. So in index notation, 125 can be written as 5 multiplied by 5 multiplied by another 5. That is 3 5's that we are multiplying together. So in index notation, we write that as 5 raised to the power 3. So it means that 125 is 5 raised to the power of 3. Another example that we're considering is to write 81 in index notation. Now how do we do that? First off, we need to list out all the factors of 81. That is 1, 3, 9, 27, and 81. And then we'll combine two of the factors such that when we multiply them together, we arrive at 81. I will be choosing 3 and 27 because I know when I multiply 3 by 27, I get 81. Now we need to also break down 27 into its own factors, and that gives us 3 and another 9. We also need to break down 9 into its own factors, that is 3 times 3. So we therefore arrive at 3 times 3 times 3 times 3, giving 81, and that is 4 3's, and that gives us 3 raised to the power of 4. So 81 simply means 3 raised to the power of 4. Now another example is to express 108 as product of prime factors. Now we're trying to break down 108 into products of prime factors. So we only need to use prime factors to break down 108. and we are going to select 3 prime factors that will be used. 2, 3, and 5 are the most common prime factors that can be used to break down numbers into their product of their prime factors. Now we use 2 first off to divide 108 to get 54. 2 again can go in 54 to get 27. 3 can go in 27 to give us 9. 3 can go in 9 to give us 3, and then finally 3 divided by 3 to get 1. When the division gets to 1, we stop there, and then we count the number of 2 we have used, that is 2. Also count the number of 3 that we have used, that is 3. So we therefore write 108 as a product of prime factors as 2 raised to the power of 2 and 3 raised to the power of 3. The next example is to express 720 as a product of its prime factors. We go again by starting the division with 2. 2 in 720 will give us 360. 2 in 360 will give us 180. 2 in 180 will give us 90. 2 in 90 will give us 45. 3 in 45 will give us 15. 3 in 15 will give us 5. And then 5 divide 5 to finally arrive at 1. Therefore, we finally say that 720 is 2 raised to the power of 4 multiplied by 3 raised to the power of 2 multiplied by 5 raised to the power of 1. In this next section, we are going to learn about common multiples and least common multiples, also called LCM. What do we mean by multiples? Multiples are numbers that are obtained when a particular number is multiplied by counting numbers, that is 1, 2, 3, 4, 5, 6, and the rest. Take for example, if I want to find the multiple of 3, it will be 3 times 1, 3, 3 times 2, 6, 3 times 3, 9, 3 times 4, 12. So the multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45. That's right. What about the multiples of 5? That is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and the rest. Now you'd notice that in the multiples of 3, I mentioned 15, 30, and 45. Also in the multiples of 5, I mentioned 15, 30, and 45. So it means that the common multiple between 3 and 15 are 15, 30, 45, and the rest. However, the least or the smallest of this multiple is 15. So therefore, the least common multiple of 3 and 5 is 15, because 15 is less than 30 and also less than 45. Now let us use this example to understand how to find the least common multiple or the LCM of two numbers. First off, we're starting with the LCM of 9 and 12. The first method we can use is by using the method of common multiples. So we write out all the common multiples of 9. That gives us 9, 18, 27, 36, 45, 54, 63, 72, and the rest. Multiples of 12 also include 12, 24, 36, 48, 60, 72, 84. You'd notice that amongst these two common multiples, we have 36 and 72. However, which one is the least? 36. So the least common multiple of 9 and 12 is 36. The second method is to use the long division method. To do that, we use prime numbers such as 2, 3, 5, 7 to perform long division on the two numbers. However, take note that when performing this division, irrespective of which of the prime numbers can go in the numbers, we go ahead with the division. So we start by using 2 to divide 9 and 12. 2 in 9, impossible because there will be a remainder, so we write 9. 2 in 12 gives us 6. 2 in 9 again gives us 9, however 2 in 6 gives us 3. 2 can no longer be used because 2 cannot go in both 9 and 3 without leaving a remainder, so we use 3. 3 in 9 gives us 3, 3 in 3 gives us 1. And finally we use 3 such that 3 divided by 3 gives us 1, and 3 divided by 1 we have 1 down. So we conclude by saying the LCM of 9 and 12 is 2 times 2 times 3 times 3. 2 multiplied by 2 multiplied by 3 multiplied by 3. That gives us 36. So the LCM of 9 and 12 using both methods arrives at 36. The next example we'll be considering is to find the LCM of 2, 5, and 10. First, we list out all the multiples of 2. That gives us 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Let us stop there. Then we list out all the multiples of 5. Gives us 5, 10, 15, 20, 25, 30. Let us stop there. And then we consider all the multiples of 10. Gives us 10, 20, 30, 40, 50, 60. Let us stop there. Now you will notice that in all these multiples, the most common one and the least is 10. So the LCM of 2, 5, and 10 gives us 10. Using the second method, we perform the long division of 2, 5, and 10. We start by using 2. 2 divided by 2 gives us 1. 2 in 5 impossible because there will be a remainder, so we write down 5. 2 in 10 gives us another 5. Then we use 5. 5 in 1 we write 1. 5 in 5 we get 5. And then 5 in 5 we also get 1. Finally, our LCM becomes 2 multiplied by 5, which is 10. So the LCM of 2, 5, and 10 using both methods gives us 10. Let us now introduce the next section of this lecture, which is the common factor and the highest common factor. What do we mean by factor? Consider the number 12 and 16. We list out all the factors of 12. That is 1, 2, 3, 4, 6, and 12. We also list out all the factors of 16. That is 1, 2, 4, 8, and 16. Now you would notice that the common factor between these two numbers is 1, 2, and 4. Now what do we mean by the highest common factor? So it means among this common factor, we pick the highest number. The highest number between 1, 2, and 4 is 4. So the HCF, or the highest common factor of 12 and 16, gives us 4. Let us use another example. We are asked to find the HCF of 36, 48, and 60. First off, we list out all the common factors of each of the numbers. The common factor of 36 is 1, 2, 3, 4, 6, 9, 12, 18, and 36. The common factors of 48 includes 1, 2, 3, 4, 6, 8, 12, 24, and 48. The common factors of 60 include 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. Now, among these numbers, what are the common factors that we find? Common factors include 1, 2, 3, 4, 6, and 12. What is the highest of all these factors? The highest of this factor is 12. So the HCF, or the highest common factor of 36, 48, and 60 is 12. I'm sure if you followed along in the course of this lesson, you will have been able to understand how to find the least common multiple and also how to find the highest common factor of several numbers. This is how we'll come to the end of this lecture. I'll see you again in the next course.